in the work that I do, what drives me, what keeps me going, is that I always strive to keep an eye on how the technology can empower the disenfranchised, how it can amplify the voices of the subaltern. And it's crucial to listen to those voices if we want to solve the biggest problems that the world faces. In product development, one of the canonical rules is that you have to understand your end users. And it follows quite logically from that the people who are best equipped to solve the world's big problems, or even to identify them as the problems in the first place, are the ones who are experiencing them. From my time working in venture capital, I can tell you that the most compelling pitches invariably come from someone who has actually firsthand experienced the pain that they are aiming to solve. And open source software is no exception. But this means that if we think that software can solve the world's problems, writing software needs to be an option for everyone in the world experiencing the world's problems. Well, 95% of the world doesn't speak English as their first language. And 89% of the world doesn't speak English at all. So let's actually raise your hand here if you speak more than one language. Okay, that's a good number of people. How many of you do not speak English as your first language? Okay, that's a good chunk. If this conference were perfectly representative of the world in every way, this entire conference, only 165 people who've attended would even be able to understand this talk at all. And of those, all but 75 would be listening to me speak in what's to them a foreign language. So if the people who are best equipped to solve the world's problems are the ones who've experienced them firsthand, this is itself a problem. We need to make sure that building software to solve the world's big challenges is an option not just for people who speak English as their first language, but for the other 95% of the world as well. So the findings I'm presenting on today are a combination of what I've encountered in my own work, both as a risk engineer at Stripe and elsewhere. And some weeks ago, I also sent around a survey for developers whose native language is not English, or developers who have experience working across language barriers. And some common key pain points emerged. Namely, if you don't speak English, or if you don't even know how to read an alphabet, Latin alphabet, even reading code requires proficiency. That's a hurdle. But things like error messages, documentation, participating in the community through events and mailing lists, all of these represent hurdles that you need to understand English or be able to participate in fully. So we're going to talk about some simple low-tech ways that we can make open source communities accessible to speakers of all languages. And we're also going to see some slick, higher tech techniques that we can apply to our code as well. Some of these will make sense for larger projects that are backed by a corporation, and some might make sense more for smaller, independent, personal projects. And some will be applicable to all projects, regardless of size. But first, it's worth reflecting on why this actually matters. Now, I'm assuming that most people who chose to come here already care about this topic, but even if we do, our coworkers and our collaborators might not, and we need to be able to articulate that to them. So let's look at this visually. That shape right there, it looks like an oval, but that's just due to the map projection. On a globe, that would be a perfect circle. More people live inside that circle than outside of it. That's more than half of the world's population right there. 1/5 of the world lives in China, and another 1/5 live in India. But that's not what the open source world looks like. As of today, only 10% of the world's programmers live in China. That's only half the representation we'd expect if programming were truly accessible to everyone across the globe. And as of 2014, only 1.4% of Stack Overflow visits came from China. Now, since then, they've actually launched a beta version of Stack Overflow in Chinese. So these numbers are no longer current, but the underlying theme is still relevant. And it raises the question that where would all of those other 86% of programmers in China go if they're not going to Stack Overflow for their information? And the answer is that they go to Chinese language versions instead. Some of these are direct clones of Stack Overflow. There's one that's literally titled Chinese Stack Overflow. But there are other community resources of all forms, just like we have in English. And it's not a phenomenon that's unique to Chinese either. There are language-specific resources targeted at speakers of Arabic, Russian, German, French, Spanish, yeah, you name it. And they're not just limited to help forums either. So for right here, you can see that the Chinese Go community has actually taken the work of translating the official Go documentation into Chinese, complete with the iconic Go Gopher mascot. And there are other projects you can find on GitHub in which all of the project collaboration, the issue tracking, the README, the comments, everything happens all in Chinese. So it's great that Chinese programmers and programmers who speak other languages have developed thriving communities for themselves. But fragmenting resources is bad for open source development. Fragmentation means duplicated work. It means incompatible interfaces. So how do we bridge these two communities, or these many communities? And it's a problem that affects non-native English speakers too. There was a blog post a while back that was titled, "More Bad English, Please." And it implored people to participate in developer mailing lists and not let fear or embarrassment hold them back from contributing, even if they feel that their English isn't very good. And from the responses to the post by non-native English speakers, it was clear that this was, and still is, a very big problem, a major point of hesitation for developers who don't speak English as their first language. The language barrier can cause them to feel disconnected from the community. They can feel like the community isn't for them, that they're not welcome. And this fragments the open source world even more. So we can agree that fragmentation is bad in both code and in community. It leads to wasted time, duplicated effort, solving the same problems over and over again with only minor variations. So how do we defragment open source software development? One possible approach is to use a common language, also known as a lingua franca. If we wanted to standardize around a single language, English would be the reasonable first choice. It's already so widely used by open source projects anyway, but that poses some problems. English is difficult to learn. Objectively, that's why we have the situation we have now, where it's actually easier for non-speakers and non-native speakers to build their own communities, to build their own websites, to maintain these separate resources, to fork them, and than it is for them to participate in English-speaking ones. And secondly, even if everyone could just learn English magically, non-native speakers are always going to be experiencing a language barrier that native speakers aren't. And so that goes against our fundamental goal of defragmenting open source software and making that accessible to everyone, breaking down these barriers. But finally, and most subtly, we think of English as a single language, but there are actually many dialects and registers. As native speakers, we don't really think about this. We're oftentimes used to switching our registers based on the context, and we're used to understanding multiple dialects and not thinking about that. But if our solution would be to use a single language, we'd have to standardize our usage of these as well. And linguistically, that's impossible. This is actually one of the reasons that the very first lingua franca, Frankic language, the Mediterranean language Sabir, died out. As its usage grew as a pidgin language, it got fragmented and it ended up influencing the local languages across the Mediterranean instead. So the languages that became modern Spanish, French, Portuguese, Italian, all of those. So it's much better for us to embrace multilingual workflows instead of fighting an uphill battle against what languages are literally meant to do, which is evolve and diverge. It's no accident that this is what we already do for programming languages. You'll notice we don't tell everyone has to use C, no matter what project they're doing, no matter who they are, no matter what they're writing. No, we recognize that different projects will use different languages, or even within the same project, we might have different languages depending on the needs. And as our languages grow, as they get more developers, as they grow in popularity, or as their needs evolve, as they are ported to different platforms, different architectures, different runtimes, they evolve as well. They form different dialects, they fork. You can see this very easily in JavaScript, for example. We have languages like TypeScript and CoffeeScript which have emerged to solve different needs. Or you can look at React Native. It's very similar to React for the web, but it's not exactly the same. And we certainly wouldn't say that React is literally the same as JavaScript. It's a variation. It involves JavaScript, but it's also something new as well. Same with C++ originally started as a dialect of C, and now, I mean, the C++ templating language is itself, many different languages altogether. So we accept this kind of divergence and accept multilingualism in our programming languages without a problem. So let's also figure out how we can do that for human languages within the same projects as well. So how do we do this? How do we make our code multilingual? And what does that actually even mean to make our code multilingual? We can go back in history. Grace Hopper was one of the first computer scientists, and she wrote the very first compiler for a programming language ever. The language that she invented, as many of you will know, was called COBOL. And the original goal was to have English-like natural language syntax so that business executives could write code. And she received incredible pushback about this. Engineers were furious. They thought, well, if business executives are going to write code, that's going to put us out of a job. And don't worry, this was 70 years ago, so it hasn't actually happened yet. But Hopper's vision actually went even further. Why should we restrict this to English-like syntax? What if developers who spoke other languages also wanted to write programs? She wanted COBOL to be, and I quote, a language you can use to talk to programmers around the world. And the response to that part was even more vitriolic. Basically, people said, well, how can we teach American computers to run German programs, German code? And to be clear, this was not a technical question of how do we do it on a practical level. It was very much a political one. Even though this was a decade and a half after World War II had ended, the fear of a threat from Germany or from Russia still loomed strong in people's minds. So the idea of opening up American hardware and having that accessible to German programmers and German code or Russian code was anathema to people. But even if Hopper's idea was put on the back burner due to xenophobia and politics in the 1950s, we can still look at what that means today. This is Hopper speaking many years later about what COBOL meant to her. She said, I would have thought that it would be useful to NATO because they had the common verbs for things that they were going to do. And the nouns, they just have to have a dictionary for the things they were referring to for inventory control. They'd have common nouns throughout NATO, and they could make a dictionary of common verbs and translate the program. You could write one in English, and you could translate it, and it could go to the other language. No problem, you'd have communication. It would be a limited vocabulary. As just a tangent, Hopper chose the imperative mood for a verb specifically because she believed that it would be universal to all languages. Not all languages distinguish readily in grammatical form between present, past, and future tenses, but most languages generally have a way of commanding people to do something. And so COBOL was one of the first languages which popularized imperative programming style, and this has stuck with us to today. That's why most languages, the directives, the keywords, we all use the imperative form of verbs. Now, COBOL, unfortunately, was invented before structured programming had really caught on with ALGOL. And today, we might take it for granted that good programs have things like subroutines, functions, loops. But believe it or not, that wasn't actually known in Hopper's time. So what would Hopper's vision look like in a modern and structured programming language? That is to say, how would we translate this Hello World program, which is written in Go, to a different language? We'd probably get something like this, assuming that, of course, we could feed it to the compiler and have it run. Now, we've left the identifier names intact, like main, format, main, true, but the keywords are all now in Bengali. So that right there is the first challenge. The Go compiler won't just understand what you're doing if you try to throw unrecognized keywords at it. But if you speak Bengali, this is great. You can understand this readily. It's not so great for communicating, though, with programmers who don't speak Bengali. So we need a way to bridge that gap, or else we're just continuing with fragmenting software development. So we need a way to automatically switch back and forth. And fortunately, we can. So enter Coro. Coro is an extension of the Go compiler and toolchain to support Bengali, exactly as I described. The name Coro is idiomatically a rough translation of what the English name Go means. Coro uses Bengali translations of all of the Go keywords, but it otherwise functions exactly the same way. So here's a hello world in practice. Hopefully you can see it. So there's just the program that we had before, hello world. And there you go, you run it. But remember, our goal is to defragment the open source community, not to fragment it even more. And so we need to make sure our code is interoperable with code written by English-speaking Go developers. So let's translate this Coro code back into English Go. So we're starting again with the same program, and we use this program, or we use this utility to generate the corresponding English code. And just to demonstrate that it does exactly what we think it does, let's write that to a file and run it. There we go. So how does this work? Go source code is already UTF-8, so it has no trouble dealing with non-ASCII or non-extended ASCII keywords. There are a few internal checks that ensure that non-Latin and non-alphanumeric characters are excluded from keywords, but it turns out that you can actually just disable those without any issue. So all we have to do is extend the lexer to handle the Bengali translations of each keyword and, of course, figure out what those should be. So some of these translations were pretty easy, like for, if. Some of them are really fun to think about, like fall through, for a switch statement. How do you actually translate that into another language? It's a metaphor. It doesn't even make sense literally. But for those of you keeping track at home, this is all done purely by the lexer. The parser actually has no idea that anything has even changed. And that's not something that you can do easily in most other languages which use flex-based lexers, because flex and lex don't support multi-byte code points, which Go's lexer does. You can accomplish the same goal in pretty much any language, but you have to dig a little bit deeper into the parser to get it to work. It requires some more effort. As for the translation step, Go already has a handy utility for formatting source code called GoFormat, or GoFunc, depending on who you ask. And mostly, we just use it to prevent bike shedding over things like the tabs versus spaces argument. So instead of arguing over the proper way to format source code, everyone just can set up their editor the way they want. So if I want to use 4 spaces for indentation and you want to use 2 spaces, that's fine. GoFormat means that we can still work together harmoniously. We set up our editors to use the width to render tabs with the width that we want. And then after we save our code, we run GoFormat, and it will automatically translate our code to this standard style. No work needed. And in fact, we don't even need to be aware that we have different indentation preferences, because the code that actually gets committed is in the standard form, and our editors simply display it in our preferred forms. But GoFormat can handle a lot more too, like removing unnecessary parentheses or even simplifying expressions. And it's also syntax aware, so it's smart enough that it will never actually change your code semantics. Which is another simple way of saying that it's a great way for performing fully isomorphic translations of source code. And we can extend it and repurpose it for translating English Go code into Bengali or Bengali Go code into English. And that's exactly what GoFormat does, as you saw a moment before. So the same way that you don't know that I was using 4 spaces and I don't know that you were using 2 spaces, having bidirectional translation layers means that you don't even need to know that I'm writing my code in English, and I don't even need to know that you're actually writing your code in Bengali. We can localize our source code as a commit hook. So as a developer, Coro means that we only ever need to be able to look at source code in our own native languages. So as far as the source code is concerned, our language preferences are no more of a barrier between you and me than our indentation preferences or editor preferences. And that's the way it should be. So we translated the keywords, but you'll notice that we didn't touch everything. Like the package and the variable names, we left those intact. And lots of ink has been spilled on the topic of choosing good variable names. The one thing that everyone seems to agree on is that variable names should be both descriptive and concise. And then, of course, no one agrees on what descriptive or concise mean, but that's another topic. So if we leave the variable names in English, as most open source projects do, that's not going to be very descriptive to someone who doesn't speak English. We need some way to translate those as well. Well, in reality, many variable and function names are already quite highly structured. Or to put it in the terms that Hopper mentioned earlier, we already have the verbs that we use quite frequently when we're writing code. So getters and setters are pretty standard. Build is a common pattern if you write Java. If you write Ruby, to foo is a way of expressing that you are going to be converting a type. So we can take advantage of this knowledge, this structure that we're already using, and translate those in the translation step as well. By being a little bit more conscious of the conventions that we're already using, we can make our code much more accessible to non-English speakers. So if we know that getFoo means that it's an accessor method for foo, we can say that accessor methods for fields are translated in this way. Setter methods, mutator methods for fields are translated this way, and so on. We might not get all of the translations for free, but we can get many of them, enough to make a difference. Now, while it's fun to talk about fully automatic isomorphic translations of source code between arbitrary sets of languages, that's not all that it takes to make open source development accessible to non-English speakers. So we've all struggled at some point with software that's undocumented or poorly documented. And if we want to fully bridge the divide, we need to make sure that non-English speakers have access to this information as well. But of course, how do you open up your project to languages if you don't actually speak them yourself or have any speakers yourself? We might not have Captain Kirk's Universal Translator or the Babel Fish from Hitchhiker's Guide to the Galaxy, but we do have tools that can help us. And I'm sure I'm not the only one here who's amused themselves by trying to see how Google Translate will mangle idioms in languages or stumble over words that have multiple meanings. But tools like Google Translate can actually work quite well for technical documentation. And there's a secret to this. It's that automatic translation works quite well for specialized and technical text for any domain, not just software, as well as text with very narrow context. The reasons for that we won't get into, but fortunately for us, that describes open source documentation quite well. We're not looking to bridge all communication in every context between every pair of languages. We're just looking to bridge communication within our context, within open source software development, between the languages that we need. So let's actually look at that in practice. Here's the opening text for the Python documentation on regular expressions. You don't have to read it all. It's pretty standard technical documentation. But let's see what happens when Google tries to translate that into Bengali. There you go. So how many of you can actually read this, by the way? Anyone? OK, that's what I thought. So if you don't read Bengali, this doesn't actually look very impressive. And I could tell you that this is a pretty good translation and ask you to take my word for it, but that's a little bit anticlimactic in a talk like this. So let's actually see what happens if we try to translate this Bengali text back into English and use that as a proxy for how much information gets lost at each step of the translation. By the way, can you read this? I'm not entirely sure. OK, I'm seeing some nods, at least from the back, so that's good. So the first paragraph, which describes what regular expressions are, it falls a little short. You can tell that it has something to do with matching strings, but it's a little bit clumsy. The second paragraph, though, is absolutely spot on. It said if A and B are both regular expressions, then AB is a regular expression. In general, if you are a match for a string P and another string Q matches B, the string will match AB, PQ. This holds unless A or B contain low precedence operations. So the emphasis, the bold, is mine, but everything else is exactly what Google Translate provided. The punctuation, the capitalization, all of that. Bengali doesn't even have capital letters, but it was able to translate that back correctly from the context. And for the third paragraph, the original said, a format, brief explanation follows, a gentler presentation. We still even get the idioms, follows, gentler. So maybe you're still skeptical. So let's try actually translating the original text into Spanish, translating the Spanish text into Bengali, and then translating back to English, and see, well, what if we add an extra step to the mix? When we do that, the first paragraph is still problematic, but it actually works better with the additional translation step than it did the first time around when you only used one jump. And in the second paragraph, the note about low precedence operations got mangled, but the rest, which is outlining the key technical properties of regular expressions, if A and B are both regular expressions, etc., that's surprisingly readable for translating between 3 languages. And the third paragraph is still spot on. Below is a brief explanation of the format of regular expressions. For more information and a gentler presentation, consult the article Regular Expressions. And it left out the hyperlink, that's all. So you might be thinking, well, if automatic translation works so well, I don't even need to bother, right? Can't other people just use a browser extension to localize content automatically? And the answer is that that's what people are already doing. And we saw the numbers. It's not working. The reason it's failing isn't just because automatic translation isn't good enough. It's because relying on machine translation to participate in a community, it makes for a really alienating experience. It doesn't make people feel welcome or encouraged to participate. When I surveyed people, this was one common point. One of my coworkers even said that when he was first learning to program, he used French websites, and even though he did speak some English, and it took him years before he felt comfortable participating in English-speaking forums. And as we saw earlier, even people who do speak English reasonably well, but as a native language or as a non-native language, they're already hesitant to participate in communities that they perceive as English dominant, that they don't think are meant for them. So the goal with automatic translation is to signal interest. You're just planting the seed. You're letting people know, yes, we are interested in you. We're interested in your contributions. We're interested in reaching out to your community, to your language group. It takes time for this to happen, but it's not going to happen automatically. We need to make the active effort. We need to reach out. We need to do that work ourselves. And once we've planted the seed, you might be surprised how many speakers of other languages are drawn to your project. But you don't have to wait for that. Actively reach out within your open source project, within your existing set of contributors and users. You might not speak Spanish or Russian or Hindi, but there's a good chance that someone who already uses your project or works on your open source project does. And go to almost any conference organized around a specific piece of open source software, and you're almost guaranteed to hear an entire talk dedicated to how do we encourage more people to contribute to this project. Even today, we heard people talking about this, and this is a conference just about open source programming in general. Well, it turns out that asking for community translations is a great way to engage people who are developers and are already, say, users of your project or your product, but haven't actually taken the step and made the jump to submitting their first pull request to your project, actually becoming contributors themselves. The key here, though, is that you have to ask for it. And it might sound very obvious that I'm saying it here now, but it's not actually something that your users are going to think to offer unless you actually make a clear point of soliciting it. They're not going to think that that's something that you're interested in or that that's a need that you have. And it doesn't have to be overly elaborate. Create project milestones. File tickets in GitHub issues. Label them by language so that people can easily filter and see what's needed and what they're able to provide. Here's what that might look like. You have labels. This one is particularly for docs. We have a checklist, to say that these are different steps that need to be done. And critically, we say that this in particular is Korean. So someone who speaks Korean would be able to filter and say, well, these are the things that I'm able to lend support with. Once you have people eager and excited to provide local translations, error messages are a great place to start. As developers, we've all struggled with cryptic error messages. And this one is one of my favorites from Java. Cannot cast parameter type from type system.string to argument type system.string. Does anyone actually know what this means? OK, there's a punchline. I'll tell you afterwards if you're interested. But you can really tear your hair out trying to figure out what's going on here. But the only thing worse than a cryptic error message is a cryptic error message in a foreign language that you don't even understand. And so error messages are a great starting point, because not only are error messages typically finite in number for your project, at least the error messages are likely to run into, but translating them has a huge impact on your collaborators as well. And these are also already the easiest to solve from a technical perspective, because we can use existing localization strategies that we use when localizing products. And there are many great resources on that. Many languages already have libraries that assist with this, that provide variants of specific concrete textual strings depending on the designated locale. And documentation is the next easiest. Providing alternative forms of documentation, even condensed, also, like error messages, has an incredibly high impact on developers who don't speak English. And fortunately, we have an existing model for how to present the same information in multiple different languages. Wikipedia does a great job of this. Every page has a list of languages in which that same information can already be found. Now, and of course, if a language is missing, anyone can add it themselves. Now, the GitHub Wiki doesn't support this directly, but you can accomplish the same goal by creating that index for yourself manually for the languages you already support. And if it's something you'd be interested in, if GitHub would support, I hear there might be some GitHub employees at this conference that you could talk to. So now it's possible for information to diverge between different language versions of the same page on a wiki. And this is something that even Wikipedia has happened, so it's bound to happen on a smaller open source product as well. However, having that divergence, but having it centralized as part of the main project, is still vastly preferable to having multiple resources scattered all across the web with no real knowledge or awareness of each other, which is what we have now. And it's certainly much better than limiting those who want to participate in and contribute to your project to proficient English speakers only. Now, localizing live events like meetups and conferences is admittedly a bit trickier. For conferences, consider hiring professional interpreters. These include non-English or non-native speakers. The key here is to find interpreters who have experience with translating technical topics, because not all interpreters will be trained in that vocabulary, the same way that not all English speakers understand technical jargon. And a separate approach is to get live stenography. Some of the best conferences that I've been to have done this to provide live captions. And it turns out GitHub Universe is doing this as well. Now, captions are going to be in English, but they can help people who speak English as a non-native language, because reading captions is often much easier than trying to catch words as they're spoken in real time, especially if people are speaking quickly like I tend to. If you mishear something or miss a word, you can go back. You can read what's going on. Now, of course, live captions are also useful for a whole host of other groups, like people who are deaf, people who are hard of hearing, people with ADHD or auditory processing disorders, and so on. And it can be a great way to include them as well. Now, for live stenography, I'd recommend these two groups. I've personally been to events around the country where both Steno Knight, CART, and White Coat have been providing captions, so I can testify their effectiveness firsthand. I'm told that Manifold is the group that's either providing or organizing the captions for this event as well. So both of these specialize in stenographic services, which is called CART, for technical topics specifically. And that's just as important as it is for interpretation, for stenography. Now, a lot of key project collaboration happens over mailing lists, and so it's hard for developers to be first-class citizens of open source development if they can't participate in conversations around project direction or technical discussions. As we saw earlier with the More Bad English Please post, even non-native speakers don't always feel welcome participating in developer mailing lists. Now, More Bad English Please encourages people to participate even if they aren't confident in their own English skills. But what if we take that a step further and encourage people to participate in their native languages if they feel that that's the way that they can best express their thoughts? Just as with documentation and errors, there's a good chance that there are others who would be willing to bridge the gap and translate or summarize for them. Encouraging native speakers or people to write in their native languages is also a great way to make non-native English speakers feel more comfortable using imperfect English on mailing lists as well, because it establishes your project as accessible to people of all linguistic backgrounds. And the same way that Wikipedia offers alternative versions of an article in different languages, we could do the same on our mailing list archives. This is what that might look like. This is a German language Debian mailing list, and we could have, for example, right there, like Spanish, English, Chinese. We could provide links to community translations or links for people to provide those. Even if not every message gets translated into every language, it provides the space for that to happen when it's needed. And it's much better to centralize this information within the project archives than it is to force non-English speakers to replicate it elsewhere, or to fragment developers by language groups, or to preclude them from participating entirely. So we've looked at a number of different approaches to including non-English speakers more in open source development. And some of these are pretty straightforward and low tech, and some of them involve building new technology and tools to solve the problem. And it's always exciting to build new tools. And if anyone's interested in going home and working on some of the systems I outlined, like mailing list archives that can be localized, or extending compilers to support non-English languages, I'd highly encourage you to do that. But let's also not underestimate how effective some of the more straightforward approaches can be, and that we can all take part in. As I said at the beginning, at the end of the day, we're all here because we want to have an impact. We want to change the world. And we think that software, particularly open source software, is a really powerful tool for doing that. And while technology is key to making that happen, social change isn't just about building the fanciest technologies that we can. It's also about improving and mobilizing technologies we already have. If you want another example, look at efforts to eradicate polio around the world, or combating HIV prevention efforts. Those wouldn't be possible without the polio vaccine or without antiretrovirals. But at the same time, the major breakthroughs that we've had in recent years, the cutting edge, it isn't just around developing new medicines. We've had those for decades. It's around providing the infrastructure to get those medicines to the people who need them when they need them. It's about providing the money, about providing the resources. So if we think that technology, if that open source software can change the world, let's prove it. And to do that, we need to make sure that developing open source software is an option, not just for us, but for the other 95% of the world too. So let's commit ourselves to doing that. Thank you. I think there might be time for like one quick question. Anyone have any?
How easy would it be for me as somebody who knows one other language to take what you've done with Coro and try to replace things to do it that way?
Almost trivial. In fact, you can honestly do it with Google Translate if you want and you're dedicated to. Coro is something that you can look at. It's on GitHub. Go back here. You can look at how I did it. It's really just a matter of stubbing out the keywords and what tokens that they're going to map to. And you have to do a little bit more around the formatting, the translation side, but it's pretty rote. It's pretty straightforward. Doing it in other languages is a little bit more technically complex, but it's still pretty abstract. If you figure out the way to localize languages or localize a particular compiler, plugging in whatever language you want to translate it to is very straightforward. So please go home and do that. Localize all of your favorite languages. So I think that's time, but I'm happy to talk to people afterwards. Thank you.